All right, let us start with quick definition and terminologies. We are interested in the behavior of the function, and we want to describe the behavior in terms of maximum, minimum, and so on. So suppose we have a function f, and we have point C or number C in the domain D. If this function value f of C is greater than all function value, so we say f of C is called the absolute maximum if this function value is greater than or equal to f of x for all x in the domain. So the largest value, function value, is the absolute maximum. Similarly, we say f of C is absolute minimum if f of C is less than or equal to f of x for all x in the domain. Equivalently, we say f of x has the absolute maximum at x equals a, or we say f of f has absolute minimum at x equals a, sorry, x equals c. So those maximum and minimum values are called extreme values. So you can also restrict your attention to certain domain. Suppose you have some interval, and if f of C is greater than or equal to all function value for all x near C. So you think of some interval containing C, and you compare that f of C and f of x. If this function value is greater than or equal to f of x for all x near C, we say this function value is local maximum. And similarly, if f of C is less than or equal to function value for all x near C, then we say this f of C is local minimum. In the next slide, we will look into more examples to make sure what those terminologies stand for. So here is a quick example to make sure that those terminologies stand for absolute maximum, minimum, and so on. So look at this graph. So we have a function whose graph looks like this on the interval from a to s. Looking at this, you can tell your function has absolute maximum at s. So that's it. Your function has absolute maximum at x equals s. What about absolute minimum? This will give you absolute minimum. So your function has absolute minimum at x equals r. And then local minimum and local maximum. Well, this will give you local minimum as well, because when you think of some interval containing r, this function value is the smallest value, on this interval. In that sense, this function value is also local minimum. Similarly, if you think of this interval, this function value f of b is the smallest on this interval. So we have two local minima. So local minimum at x equals b and this value r. For local maximum, well, you can think of this interval, and this value is the largest value on this interval containing c. So in that sense, local maximum is at c. What about a and s? Well, those two outer values or endpoints a and s can give you absolute maximum or minimum, but when it comes to local minimum and maximum, we do not consider two endpoints. So let me point it out. So those two endpoints cannot give you local maximum or minimum. So here is another example. The first function is piecewise function. In the first interval, we have quadratic function 16 minus x squared. Now that we have negative coefficient, our parabola is concave downward. So we have this graph from -4 to 0. So we don't have equality for this x equals 0. So we have here whole, or x equals 0 doesn't give you this value. Instead, x equals 0 will give you 0 minus 2. So this value, -2. And in the second interval, we have straight line, or 2x minus 2. So the graph of f looks like this. And you want to tell whether the function has absolute maximum or absolute minimum. Here, let me change this condition a little bit. Here, I'm adding equality symbol. X can be 4. So I'm putting dot for this value, x equals 4. Okay. For this function, well, you can tell definitely f has absolute minimum. So f has absolute minimum. F of 0, which is -2. What about absolute maximum? It doesn't have absolute maximum because look at this. Well, when you plug in x equals 0, you will get 16 if it was defined there. But this 16 or that value cannot be attained in f. So any value less than 16 can be attained in this graph. So in that sense, your function has no absolute maximum. So no absolute maximum. Okay, so this function has only absolute minimum. What about this? This function is very nice function, continuous everywhere, differentiable everywhere, but this function has no maximum, no minimum. No maximum, no minimum. So one natural question is, when does a function has both absolute maximum and absolute minimum?